All right, 8.3 Trigonometry, Part 1. We're going to talk about ratios and sides. All right, objectives. Students will be able to find trigonomic ratios using right triangles and solve for missing sides using trigonomic ratios. Okay, real quick, trigonometry, this word trigonometry, it literally just means triangle measure. So all we're really talking about when we talk about trigonometry is we're talking about measuring triangles, or the measure of sides and angles of triangles. Okay, before we even start to do trig, I need you guys to remember this acronym. And in class I told you the story. I'm sorry to tell you the story was made up, but the name is really important. It's SOHCAHTOA. If you can remember this name, or this, I guess, acronym, SOHCAHTOA, trig will be a piece of cake for you. So what it does is it helps us set up some trig ratios. And we have 3 trig ratios. We have sine, cosine, and tangent. And the SOHCAHTOA acronym helps us know what each of the ratios are equal to. Notice you have S for sine, C for cosine, and T for tangent. The SO in SOHCAHTOA is for the sine ratio, and the sine ratio is always going to be the opposite over the hypotenuse. So opposite over hypotenuse. The cosine ratio is always going to be the adjacent over the hypotenuse. And the tangent ratio is always going to be the opposite over the adjacent. So this is just a clever way to help you remember these 3 ratios. Now, what does that mean? When I say sine of A, what do I mean by opposite over hypotenuse? Well, first, we find angle A, because this is always going to be an angle. This is the sine of an angle, the cosine of an angle, the tangent of an angle. So we find that angle that they're talking about. And opposite means that it is across from that angle. Adjacent means that it's touching that angle, but it's not the hypotenuse, because the hypotenuse is always the one across from the right angle. So these will change, because if I said B, and I asked for the sine of B, well, the opposite of B is now this side. So these things change depending on what angle we're talking about. Let me give you an example. It says find sine R, cosine R, and tangent R. Well, the sine of R, well, let's look at R. R is right here. And in order to do the sine, I have to do the opposite of R over the hypotenuse. So here's R. The opposite of R is 4. So sine R must be 4 over the hypotenuse, which is 5. So what's cosine R? Well, cosine is always the adjacent over the hypotenuse. So let's look at R. And there's 2 segments touching it, but the adjacent is always the one that's not the hypotenuse. So we have 5 here as the hypotenuse. So 3 must be the adjacent. So we do 3 over the hypotenuse, which is 5. And finally, we have tangent of R. And tangent of R is the opposite over the adjacent. So we go to R, 4 is the opposite, and 3 is the adjacent. So that would mean the tangent of R is 4/3. All right. I want you guys to try this one now. Now you're going to be doing the sine of S, the cosine of S, and the tangent of S. So think about where S is, think about what's across or opposite of S, what's adjacent to S, and make those 3 ratios. So go ahead and give that a try, and then unpause the video when you're ready to check your answer. Okay, so here's what you should have had for sine of S, cosine S, and tangent of S. And I want you to notice something interesting that happens here. You'll notice that the sine of R is actually the same thing as the cosine of S, and the cosine of R is actually the same thing as the sine of S. And the tangent of R is the reciprocal of the tangent of S. These are some patterns that you'll kind of understand more as you play with these more, but these are going to always be true in right triangles. Now, every year, students always ask me, now what does a sine function do, or a cosine function do, or a tangent function do? What does it do? Well, all trig functions do is they convert angles. So for example, if I knew what R was and plugged it into tangent, it converts angles to ratios of sides. So the sine function converts the angle here to the ratio of opposite over hypotenuse, or the cosine function converts this angle to adjacent over hypotenuse, or the tangent function converts it to opposite over adjacent. That's all it does. All right, so let's apply it to some more problems. Okay, next, example 2 here just says use a calculator to find each trig ratio as a decimal. Remember, the trig functions just convert this angle to a ratio. So everybody's calculator is a little bit different, so you either are going to have to plug in the 39 first and then the cosine if you have an old calculator, but most modern calculators let you just press the cosine button, then 39, and then hit enter. You do need to make sure that your calculator is in degree mode. And if you're not sure how to do that, you're going to have to ask me in class and I can show you. But basically, you just go ahead and put in cosine 39 in your calculator. I'm doing this off on the side on my calculator. And hit enter, and you get a decimal. That decimal is a ratio. My decimal that I get when I do cosine 39 is 0.777. Now, I forgot to read what it says. It says to the nearest hundredth. So the nearest hundredth here would be 0.78. And I know it doesn't look like it, but that's a ratio. I mean, let's think about this. What is 0.78? Isn't it just 78 over 100? And so if the cosine of 39 is 78 over 100, that would mean that the adjacent and the hypotenuse, the ratio between the adjacent and the hypotenuse, would be 78 to 100. Just a little way of thinking of it. So, but right now I just want you to practice plugging this in your calculator and seeing what you get. So I kind of talked about how to do it here. Go ahead and try it. If you didn't get 0.78, try doing it couple different ways. Try putting in the 39 first and then the cosine and hitting enter. And also check and see if you can make sure you're in degree mode. So in your calculator there will be a few different modes. And you want degree mode, but there might also be rad mode. Okay, so make sure that it's in degree mode. That's the one you want. Okay, go ahead and give that a shot. I'll put the decimal ratios up here, and you can check and see if you did it correct. Okay, so here's what I got. I got about 0.92. I got 1.11. And for sine 89, when you type in sine 89, you get 0.999. And of course, if you were to round that to the nearest hundredth, it would just be 1.00. I could put 0.00 here. Now, obviously, that's not true. The sine ratio is not 1 because, again, that would mean that remember, what is sine? Sine 89. Remember, that's the opposite of the hypotenuse. So this would say that if the opposite is 1, the hypotenuse is 1. So it's a 1-to-1 ratio. And that's not completely true. It's pretty close, but it's not. So this rounding kind of creates a problem for us. Okay, so let's go ahead to the next one. Let's talk about how we can use this to solve for a missing part. Okay? And let's just read this real quick. It says, when solving a triangle for a missing side using trig, ask yourself, what side do I know and what side do I want to know? This will tell you which trig function to use and the ratio to use. So it's a good way to think of it. So we want AC. I'm going to just put a little X here. If I'm looking for AC and my reference angle is 65, that looks like then X would be my adjacent, and 7, which I know, right? 7 is what I know, and X is what I want to know. 7, which I know, is my hypotenuse. So I have to ask myself, which one uses the adjacent and the hypotenuse? Well, SOHCAHTOA, CAH, C-A-H. So we could say that the cosine is what uses the adjacent and the hypotenuse. So therefore, the cosine of 65 must be equal to the adjacent, which we could say is X, over the hypotenuse, which is 7. And now I have X divided by 7. If I want to get the X all by itself, I just multiply by 7. 7's cancel, and now I have the answer for what X is. This is the exact answer, but if I wanted a decimal answer, I could just plug this into my calculator now. 7 times the cosine of 65, and I get that X is approximately 2.96. And there we go. So before we move on, I want you to go ahead and try and see if you could find BC. Okay, Okay, what if you're trying to find BC for the same problem? So now think about what you know and what you want to know. You still know the hypotenuse. And technically you know the adjacent, but I wouldn't use it because it's not exact. The only one that you have that's exact is the 7. And now you want to know BC. So maybe you might want to call it y, just to make your life a little bit easier. So how would you find y? Think about what trig function you would use, and you would figure that out by asking yourself, what side do I know, and what side do I want to know? So I'm going to let you go ahead and just give that a shot, and then I'll put the information up there in just a second. Okay, so we want to find y, and we know 7, the hypotenuse. Y is across from our angle, so it's the opposite. So which function uses the opposite and the hypotenuse? That's sine. So I started off by saying what's in red here, that the sine 65 equals the opposite, which is y, over the hypotenuse, which is 7. And then I just solved for it. Cancel out my 7s. Here's 7 sine 65. When I plug that in my calculator, I get about 6.34. So that's how you do that kind of problem. Let's talk about this one now. This one's a little bit different. This one says find AB using trig. Okay, well now AB here is the hypotenuse. So again, let's just call it x. And right away I'm seeing from my reference angle of 50 that I have an opposite and a hypotenuse. So I'm still going to use sine, because sine is the one that uses opposite and hypotenuse. Opposite, hypotenuse. So kato, it tells me I'm going to use sine. So the sine of 50 has to equal my opposite, which is 6, and my hypotenuse, which is x. All right, a while ago, I told you that when you have a variable in the bottom and some number over here, you can just flip these two. If you're not sure and you want to do some algebra, go ahead and multiply both sides by x and then divide both sides by sine 50. But basically, the shortcut is you could just switch these two. We've done that several times, so I'm not going to really go over the algebra for that. So the solution for x is just going to be 6 divided by sine 50. So 6 divided by sine 50 in my calculator is approximately 7.83. And there we go. I want you guys to go ahead and see if you could find AC in the triangle above. Again, don't use x because it's not exact, just use the 6. So the information you do know is 6, the information you want to know is AC. Go ahead and give that a try, and I'll put the answers up in just a second. Okay, if I know 6, which is the opposite, and I want to know y, which is the adjacent, I'm going to have the opposite and the adjacent. That's tangent. So the tangent of 50 equals the opposite, which is 6, over the adjacent, which is y. I know that I can just switch these two, so y equals 6 over tangent 50. I plug this in my calculator, I get 5.03. So now I've found the missing sides. Now the cool thing about this is I could check this. Now again, I rounded here and I rounded here, so it's not going to be exact, but it should be really, really close. I could plug y in, or 5.03, into the Pythagorean theorem, so I could square it, plus 6 squared, and it should equal x squared. Kind of a neat little thing. All right, now we get into the real fun part. This is where it gets real interesting, because you're going to start doing some word problems where you have to find missing parts of triangles. In order to do that, you're going to have to draw some triangles. So this one says Dakota is standing on the ground 97 yards from the base of a cliff. So let's draw our cliff. Let's draw the base of the cliff. And here is Dakota. I'll put a little D there for Dakota. Okay, so Dakota is 97 yards from the base of this cliff, and we could go ahead and assume that that cliff is going straight up and down. And then let's see, what does it say yet? Next says using a clinometer. A clinometer is just something that measures angles. So using a clinometer, he noted that the angle formed by the ground and the line of sight to the top of the cliff. So line of sight to the top of the cliff, so we could draw that in, is 56 degrees. Find the height of the cliff to the nearest yard. Well, this looks like the height here, right? Let's call the height x just to make it easy. And I have this angle. I know the adjacent side, and I want this height, which is the opposite side. So since I'm using the opposite and the adjacent, sounds like I'm going to use tangent. So I'm going to say the tangent of 56 equals the opposite, which is x, over the adjacent, which is 97. Now I'm just going to do some algebra, and I get 97 times tangent 56. This is a good time to tell you, by the way, that this tangent 56, this is its own thing. You can't distribute this 97 in here. You have to do this first, okay? So tangent 56, what you're going to have to plug in your calculator, and then multiply it by 97. So let's go ahead and do that. 97 times the tangent of 56 is 143.8. Now they said to the nearest yard, so the nearest yard would actually be 144 yards. So that cliff is 144 yards high. So pretty cool. We were able to do that. All we had was a distance and an angle, and we were able to find the height. It's pretty amazing, really. Okay, I want you to try this one. Remember to draw it out. Give it a shot, and again, I'll put my solution up in just a second, but go ahead and try it first. Okay, so the first thing I had to do is draw an accurate picture. They said I had a 50-foot flagpole. They said that she was some distance away from the flagpole, and that the angle formed by the ground and the line of sight to the top of the flagpole is 14 degrees. Well, once I draw this out, I can see from my reference angle of 14 that I have the opposite side, and I want to know the adjacent. Opposite and adjacent means that I'm using tangent, so I write tangent of my angle equals the opposite over the adjacent. And that means that I can just flip the x with the tangent, as we talked about before. Go ahead and plug this into my calculator, and I get that x must be 200.54 feet. So she must be 200.54 feet away from that flagpole. Again, pretty cool. Pretty cool. Okay, that's it for part 1 of Trig. I'll see you guys on the next video.